In this video, we will sketch the graph of the function f of x based on the information that appears on the left-hand side of the screen concerning asymptotes and the first and second derivative. The first thing we will consider is the information that appears in the red box, which tells us that the function is continuous for all x except x equals 2, and that f of 2 does not exist. We can also see there's some limit information, and we have that the limit as x goes to minus infinity of f of x equals 0, which is telling us there's a horizontal asymptote. The limit as x goes to plus infinity of f of x is infinity, which tells us that there is no horizontal asymptote in that direction. And the limit as x goes to 2 of f of x equals minus infinity, which is telling us that there is a vertical asymptote at x equals 2. And we're going to record that information on the graph. Here is the information that there is a horizontal asymptote y equals 0 as x goes to minus infinity, which is what this limit tells us. Here's the information that there is a vertical asymptote at x equals 2, which is this information. And notice it also tells us that the graph heads towards minus infinity on both sides of 2. And then finally, this, the limit as x goes to plus infinity of f of x equals infinity, tells us that there is no horizontal asymptote on this part of the graph, and in fact the function gets arbitrarily large as x gets positive. Next, we look at the first derivative, and we discover that the first derivative is positive on minus infinity 0, union 2, 4, union 4, infinity, and f prime of x is negative on 0, 2. So what we do is we draw a sign chart, and we include that information. Next, we translate that into increasing and decreasing, and we discover that the function is increasing on minus infinity 0, decreasing on 0, 2, increasing on 2, 4, and increasing on 4, infinity. Notice that we also have information that the first derivatives are 0 at 0 and 4, so both 0 and 4 are critical points. 0 is a local max. 4 is a local nothing, but it is a critical point. Next, we consider the second derivative, and we have information about where it's positive and where it's negative, and that information is recorded on the sign graph. So we use that information to conclude where the function is concave up and concave down. And notice again that we have to include a break at the asymptote x equals 2. Now we have most of the information that we need to draw an accurate sketch of the graph. The only thing we really need is a few points that we know for sure on the graph, and those are given by these values. You can see that we have included those values on the graph. And now we're just going to start drawing the graph. So the first region we want to consider is this one, when x is less than minus 1. Over here we can see that f prime is positive, which means the function's increasing. F double prime is positive, which means it's concave up. The picture must look like this. Now, in the next region, between minus 1 and 0, we can see our function is still increasing, but now it's concave down. 0 is a critical point, which we know is a local maximum. And on the other side of 0, the function is decreasing and still concave up. And we head to minus infinity when we approach x equals 2, as we have that information already on the graph here. Now on the other side of x equals 2, we're coming up from minus infinity, increasing and concave down. We pass through the point 4, 0, and you'll notice there's a horizontal tangent there. The reason there's a horizontal tangent is we know that's a critical point. And then finally, when x is bigger than 4, we are increasing and concave up, which gives us this shape. And based on that information, we've been able to draw a fairly accurate picture of this graph.